Welcome to today's session. Today we're going to be talking about and exploring exponents and what that will look like for the Virginia SOL. So I want you to take a moment and think about what an exponent is. So while I'm getting my video prepared, I want you to envision what exactly is a exponent. So for instance, if I saw the number or the number represented by the variable a, and that's going to be raised to the fifth power, what exactly is that? What exactly does that mean? Well, since a is the base, this is our base. So what that means for the base, I want to see the base of a. I want to see that 5 times. So there's my base a, and I want to see that 5 times. So this is equivalent to a times a times a times a times a. So the shortened version of this and the shortened way to write this would be a to the fifth power. All of these a's written out, that is our expanded form. The same thing would work if I had 2 to the fifth power. So if I had 2 to the fifth power, that would be 2 times 2 times 2 times 2 times 2. So what happens is if you have another one, like a negative number, if you're trying to raise a negative number to a power, you have to put that negative number inside of parentheses, because if you don't, it will just stand for the opposite. So if I said the whole base of -3 raised to the fourth power, that actually means you want to see -3 4 times. So that is a general synopsis of what an exponent is. Oops, I didn't need to write that. So what happens if you need to combine them, or you have a whole lot of exponent problems? All right, if we have another problem with exponents in it. So let's say, for instance, we had a to the second power, b to the fourth power, times a to the third power, b. What would that look like as a final product? Well, if I'm looking at a squared, b to the fourth power times a to the third power, b, you may think you can't multiply them. But with multiplication, it doesn't matter how you have it. If you need to, I would expand them all. So we have a times another a, and then we have b times b times b times b times. Now I'm about to work on this product over here. A times a times a times a b. What would that look like shortened? What would that look like all together in exponent form? How many a's do you have? Remember, an exponent tells how many times you want to see the base. Well, how many times do we see the base of a? Well, we got it 1, 2, 3, 4, 5 times. A to the fifth power is how we will shorten it. Well, how many times do you see b? We see b 1, 2, 3, 4, 5 times. So we also have a b to the fifth power. So the exponential form of all of that combined or simplified would be a to the fifth power, b to the fifth power. So why is this correct? So why does it work out that way? What would be the shortened way of actually doing this without expanding? That's where the law of exponents come in. If we look at this a is raised to the second power. This a is raised to the third power. And we ended up with a to the fifth power. What is the connection between a 2 and a 3? And how could you get 5? What operation would you perform? I'm sure you said in your head, well, if I did a to the 2 plus 3 power, that would end up with a 5. And then how did we get b? We have b times b times b times b, then another b. Well, this b doesn't have an exponent. How can you get a 5 out of a 4 and a Nothing. Well, technically, there is a something there. How many b's do we have? We have one b. So you could technically put a b to the first power, but that doesn't look right in math. Then all of our numbers will look strange. If I had 23, I'll have to write 23 to the first power. That will look weird, or 17 to the first power. So instead of writing it to the first power, we just leave it blank. We just don't have that there. So we have a b to the 4 plus 1 power. And when you simplify that, you end up with the answer that we got. A to the 5th power times b to the 5th power. So that is our final answer. All right, I hope that makes sense. So now it's time for us to dig in to some harder ones. What happens when you have a whole lot going on? So what does that mean? I have 3b raised to the 2nd power times 4x to the 3rd power raised to the 2nd power. What does that mean? Again, the exponent tells how many times the base. Since this 3b was written in parentheses and then the exponent is around it, we technically want to see 3b twice. So technically that problem above is 3b times 3b. If we're looking here, we have 4x to the 3rd power, all of that raised to the 2nd power. So you might say, what do I do? Well, the base has the parentheses around it. So that means you want to see that base of 4x to the 3rd power 2 times. All right, now what do we do? Well, we apply some of the same principles as we talked about before. You can multiply the numbers times the numbers. So I could do 3 times 3. So I'm just going to do some reorganizations. Then I want to multiply my b's together, b times b. Now looking over here, they're still connected through multiplication. I have 4s, 4 times 4. And yes, you can separate them. I know it says 4x, but you can definitely separate them. And now I have x to the 3rd times x to the 3rd. Let us clean this up. What is 3 times 3? That's 9. What is b times b? Well, how many times do you see b? The exponent tells me that I want to see b twice. 4 times 4, that's 16. X to the 3rd times x to the 3rd. If I were to expand it, you would see x 3 times and then x another 3 times. So how many times will we see that x? Hope you said x will be showing up 6 times. Now this looks a little weird with all this separation. There's still some work that we can do. And part of that is multiplying 16 times 9. Please feel free to use a calculator to do 16 times 9. I'm going to try to attempt to do it over here on the side. So 16 times 9. That's going to give us a lovely 144. And then we're going to finish out with just writing our b squared and our x to the 6th power. So that's how we do that in a nutshell. We're going to dig into some harder ones in a moment, but I want to show one more thing. This is how you multiply. Let's talk about what it would look like if we were to use exponents and divide. So let's say we have b to the 4th power. And we wanted to divide that by b to the 2nd power. Well, if we were to expand that, that'll be b times b times b times b. And on the bottom, it'll be b times b. Because it says I want to see b 4 times. I want to see b 2 times. So what's happening to the ones that are on top, they would cancel each other out, really becoming ones. And so we would be left with b to the 2nd power on top, or in our numerator. So we look at that and we compare, how can you get a 4, a 2, a 4 and a 2 to make a 2? Yes, through division, 4 divided by 2 is 2, but just like with multiplying, we saw the connection was addition. Division is going to have the connection of subtraction. Let's do another one so you won't be confused. If I have b to the 8th power divided by b to the 1st power, trust and believe my answer is not going to be b to the 8th. I'm going to have 8 b's up at the top, or up in my numerator. 1, 2, 3, 4, 5, 6, 7, 8. All of that over one of these. And then I will cancel one of them, and I will be left with 7 of them. So the only connection that we can make here is that b to the 8 minus 1 power is 7. So subtraction is our connection with exponents being divided. Of course, it gets more complicated than this, especially when you are dealing with negative exponents. But let's briefly talk about negative exponents. If I have b to the 5th power over or divided by b to the 6th power, if I did the subtraction method, it's technically b to the 5 minus 6 power, which is going to be equivalent to b to the negative 1 power. But what does that even mean? What does that look like? This is technically 1 over b. So before you say, huh? Let us take a look at what that would look like in expanded form. Expanded, I would have b times b times b times b, and I would divide it by b times b times b times b times b, all of these b's. And then what happens is 5 of them would get canceled. But look at what is left. There's still a b in the denominator. So somebody says, well, it's just like that. But what do you put on top? There has to be a number that you will put on top. And that placeholder will be a 1, because anything divided by itself is 1 anyway. So we did all of these b's divided by themselves, so that gave us a 1 on top, and there was 1 b left in the denominator. So keep that in mind when you want to use the subtraction method. If you don't use the expanded method, then you're not going to see it right away. You use the subtraction method, just make sure that you are aware that b to the negative 1 power is the same thing as 1 over b. Just so you are really into it, know that b to the negative 2 power, in order to create it correctly, which means you're making it look aesthetically correct for mathematicians. We're very bougie that way. We don't like to see negative exponents. This will be the same thing as saying 1 over b squared. Why that works is that negative means do the inverse. The inverse is of the reciprocal. Once you do the operation of flipping it, it flips to the denominator and it gets rid of the negative. So if I had 3 to the negative 1 power, that's the same thing as taking my 3 over 1, flipping it, and making it 1 over 3 to the first power. But because we don't need that first power, like we talked about that earlier, it'll just be 1/3. All right, I will give you a couple to try on your own momentarily, but I want to give you the opportunity to look at some other problems that you'll see on your SOL. All right, we're going to take a look at an SOL released item. All right, we take a look at this one. This one deals with division of exponents. If you would like to, go ahead and pause the video and give it a shot. It says a to the 12th power b squared, all of that divided by a to the 3rd power b to the 6th. So we know that we have to automatically use the subtraction method in order to get our exponents simplified. So if I'm looking at this scenario right here, we have a to the 12 minus 3 power and b to the 2 minus 6 power. What is 12 minus 3? That's a 9, a positive 9. What is 2 minus 6? That is a -4. But we just talked about this. We don't want to see a negative exponent. So this technically will end up being a to the 9th divided by b to the 4th. What happened is this b became 1 over b to the 4th. This a was just a to the 9th times 1 over b to the 4th. So a to the 9th times the 1 is a to the 9th. 1 times b to the 4th is b to the 4th. So that would make this answer a to the 9th divided by b to the 4th. Let's take a look at another public release item. This one says, which expression is equivalent to 18 c to the 8th d to the 9th divided by 9 c to the 3rd d to the 6th. If you would like to try it on your own, please pause the video. All right, let's take a look at it. We have an 18 divided by 9. Automatically, you have to know 18 divided by 9 is separate from dealing with these exponents. 18 divided by 9 is 2. So that automatically eliminates D and B. So let's take a look at our C's. C to the 8th divided by C to the 3rd. That's the same thing. Yes, you can separate them if you need to. C to the 8th divided by C to the 3rd power. That's the same thing as saying C to the 8th minus 3 power, which is the same thing as C to the 5th power. So our answer is going to be C to the 5th power. That's already making it A, but we can also take a look at the last one, D to the 9th divided by D to the 6th power. That's the same thing as D to the 9th minus 6 power. That will give you D to the 3rd power. So we would have A as the answer here. Trust me, it's not rigged. It's not going to always be A, but that's our answer. All right, I want to take a look at one more thing, and then I believe that we should stop and allow you the opportunity to practice the skills that you are learning. All right, what happens when it gets overwhelming like this and you have so many things to simplify? One thing you need to do and make sure that you remember is that you can take all of this in stride and treat each number as an individual. So I'm looking at this and I'm analyzing this problem. Since there are no exponents on the outside, we can pretty much remove these parentheses. So if I'm going to remove the parentheses, I'm going to deal with this 4 times -2. 4 times -2 is going to give me a -8. So I've already taken care of the 4 and the -2. My next thing to take care of is x squared. Sorry for the handwriting. X squared times x. We're multiplying. So what does that look like? What is the exponent of that x? It's a 1. So that's the same thing as saying x to the 2 plus 1 power. So that is x to the 3rd power. Next, we have the y's. I'm done with my x's. Y to the 3rd times y to the 4th. We know that's to say have the same base. That's y to the 3 plus 4 power. So that ends up being y to the 7th power. Let's look at our z's. So the y's are done. Our z times z to the 2nd. We have another z that doesn't have a power, so we could give it a 1. So that's z to the 1 plus 2 power, which is z to the 3rd power. And we can bring this all together with a nice answer. -8, x to the 3rd, y to the 7th, z to the 3rd power. That will be your final answer for number 12. Now I'm going to leave number 13 for you to try, and you will get the answer. Number 13, I want you to pause that video and go ahead and try that one. But before you do, make sure you understand, even though that says -x, you can stick a 1 in there and make it a -1x. So you don't get yourself confused. Let's take a look at 14 together. All right, if I take a look at question 14, I got to remember I have a numerator and a denominator. And so being as though we have a numerator and a denominator, we want to get some of this stuff erased, sorry. We have a numerator and a denominator. We want to deal with the numerator, and then we want to deal with our denominator after we deal with the numerator. Or you could deal with the numerator and the denominator first. It's really up to you how you want to tackle the problem. It's just like a big old puzzle piece. So let's give it a try. All right, I see that I have a 2 and a -5 on top, so I'm going to put those together. I have an x to the 3rd on top, and I also have an x to the 2nd on top. And then I have a y to the 4th on top. What I have found is if you rearrange it, it helps you to focus a little bit more. So that 2 came from here, that -5 came from here. The x 3rd came from here, the x squared came from here, and the y to the 4th came from here. And I'm gonna put all of that over 2x to the 4th, y. Now I see a couple of things I could do already. I could cancel out these 2's. That's automatic for me. Before I even do anything, I'm gonna get rid of those 2's. You could have multiplied and got -10, and then -10 divided by 2 will be -5 again. But if I see that I see something the same, I'm gonna go ahead and get rid of it. There's nothing else the same just yet. You could do some of these things in your head, but I would rather you get them together first. So I know I have that -5 in my numerator still. X to the 3rd times x to the 2nd. We gotta keep it consistent. That's x to the 5th power. Why? Because you have 3 x's and 2 x's. Together, that's 5 x's, x to the 5th power. And then you have the y to the 4th at the top. And on the bottom, you end up with x to the 4th, y. We can't leave it like this because we have some cancellations that we have to think about. You have 5 x's on the top, and not because of that 5, because that says I want to see x 5 times. And you have 4 x's on the bottom. And so we also have 4 y's on the top and 1 y on the bottom. So what will we end up with? I hope you're still tracking with me. We have negative 5x, because 5 minus 4 gives you 1, and y to the third power, because 4 minus 1 gives you 3. And so this would be our final answer. If you needed to see it expanded, I will do it here for you. 1, 2, 3, 4, 5. 1, 2, 3, 4. And on the bottom, we have 1, 2, 3, 4, and a y. What happens is cancel, 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 leaving 1 left, and cancel, leaving 3. So this is why we have negative 5x, y to the third power. All right, we're going to look at 15 together. And I want to briefly talk to you about to the 0 power. All right, 15. This says I want to see all of this twice. And we talked about what that looks like, but I did not give you the shortcut. When they have a 2 or any kind of exponent chilling on the outside, what you can do what I'm saying, write it out twice. 2x squared over 4x. There's 1 time times 2x squared over 4x. That's one way of thinking about it. But another way you could think about it is, this is like the distributive property. Everything inside of those parentheses, everything has an exponent. The exponent of the 2 is 1. The exponent of the 4 is 1. The exponent of that x is 1. And then outside of that parentheses, you had a 2. That means you're going to distribute that 2 to every single exponent. So that will look like 2 squared x to the 4th, because 2 times 2 is 4, divided by 4 squared x to the 2nd power. So what does that look like? 2 squared becomes 4. X to the 4th is going to say x to the 4th. 4 squared becomes 16, because 4 times 4 is 16. And x squared is there. Now what? We have some simplification to do. You can simplify 4 divided by 16, because 4 goes into 4 once. 16 goes into 4. 4 goes into 16 4 times. You could simplify this. You have 4 x's on the top and 2 x's on the bottom. So you will end up with x to the 4 minus 2 power, which is b x squared. The other way to write this would be 1 times x squared, which would just be x squared divided by 4. And sometimes you might see it as 1/4 x squared. Just depends on how they want to do it, but you want to be mindful and get in a habit of being able to see it in those different ways. Now, does that really translate to the one at the top? It does. The one at the top is the same thing. You would have 2x squared, or the one that I simplified it as in the top is the same. 2 times 2 would still give me 4. X squared times x squared would be x to the 4th. 4x times 4x would be 4 times 4, which is 16. X times x would have been x squared. So it depends on you which one is the best method. This distribution method works when it's like a higher number. Like just saying it twice, that's not bad. But if it had like all of this raised to the 9th power, you definitely would want to do it that way. And last but not least, I wanted to give you one more tidbit. When you are dealing with a big thing like number 17, where it's raising something to the 0 power, that means you want to see that base no times. And so what does that look like? Well, that doesn't mean that the answer is 0. It means that it is a 1. You might say, what? I don't get it. I don't get how that's a 1. Well, let's take a look at something to the 0 power. All right, 5 to the 4th power divided by 5 to the 4th power. That is technically 5 to the 4 minus 4 power, which is 5 to the 0 power. But what does that mean? It's 1. Why? Because anything divided by itself is 1. If we were to expand that, 5 times 5 times 5 times 5 divided by 5 times 5 times 5 times 5, we would get this huge number. That huge number divided by the same huge number would be a 1. And what happens is if you're canceling these, they're not canceling to become zeros. They're canceling to become 1. So when we look at a problem like 17, we have to keep that in mind. Even though they give you this crazy long base of negative 5, x to the negative 4th power, y to the 3rd power, all of that's raised to the 0 power. So what that means is all that is just a 1. 1 times 2x to the 3rd power, y to the 4th. Your final answer is just going to be 2x to the 3rd power, y to the 4th. Now that is my spiel on exponents. I hope that you have gotten some understanding and that you'll be able to do the practice.